So to factor this completely, the first thing I always check for is a greatest common factor. Is there a number that divides both terms, or do they share any variables in common? I notice that 2 divides both terms, so I'm factoring out a 2. What's left? Well, 2 times x to the 4th gets me back to 2x to the 4th, bring down the minus sign, and 2 times 81 gets me back to 162. Next, I checked what's left in the parentheses. If that could be factored further, I'm going to continue factoring. I know that x to the 4th minus 81 is the difference of squares because x to the 4th is a square and so is 81. So for difference of squares, I open up 2 parentheses. I alternate the signs, one's a plus, one's a minus, and then I take this first term and I split it in the front spots here because it's the first term there. So what can I multiply by itself to get x to the 4th? That would be x squared and x squared. And then in the back spots here, I take the square root of the second term. So again, what can you multiply by itself to get 81? And that would be 9 times 9. The 2 that you brought out from the beginning, that just goes in the very front. Yet again, I'm going to check the parentheses to see if I could factor either of these further. The first parenthesis, I cannot factor any further. It is not the difference of squares because that's a plus sign. However, I noticed that the second parenthesis, x squared minus 9, that's the difference of squares. X squared is a square and so is 9. So, yet again, I'm going to open up double parentheses, alternate the signs, one's a plus, one's a minus, and I'm going to split this front term in the front spots here. What can you multiply by itself to get x squared? X times x. And then 9 gets split in the back spots here. So what do you multiply by itself to get 9? 3 and 3. So my final answer now, the x squared plus 9 is part of our factor set here, and the 2 in the very front. So it doesn't matter what order you multiply these factors in, because multiplication can be, you can switch the order of multiplication. So there's our final factored form.